Okay, we're going to go over one of the problems from finding the distance from a point to a line on the coordinate plane. These were the 4-step problems that you'll see one on your test tomorrow. Okay, so given the problem that line L contains the following 2 points, we want to find the distance between line L and point P, which is at 2, 4. So the first step is to find the equation of line L. And we want to make sure that we get it in y equals mx plus b form. So we want it in y equals mx plus b. So the first step in doing that is to find the slope. And if you remember, slope is y2 minus y1 over x2 minus x1. And we will call the point negative 5, 3 our x1, y1, and the point 4, negative 6, x2, y2. So the slope of the following line will be negative 6 minus 3 over 4 minus a negative 5, which becomes plus 5. So that's negative 9 over 9, which becomes negative 1. After we find the slope of our line, we have to find the y-intercept. In order to do that, we will plug in our slope and one of the points in our equation to find our y-intercept. So I'm going to choose the point negative 5, 3. So I'll have 3 equals our slope, which is negative 1, times our x, which is negative 5, plus b. So that's 3 equals 5 plus b. So b is equal to a negative 2. So the last step in 1 is to plug it into y-intercept form to get our equation. So our final equation will be y equals negative 1x minus 2. So that is the equation of our line. Okay, in step 2, we want to find the equation of a line that is perpendicular to line L and passes through the point 2, 4. So if you remember, the equation for line L was y equals negative x minus 2. So if the line is perpendicular to line L, that means that it has to have a slope of positive 1. Remember, to find the slope of a perpendicular line, you flip and change the sign. So now we just need to find the y-intercept. So we're going to be using the point P, which is 2, 4. So if I plug in the point 2, 4, I get 4 equals 1 times my x, which is 2, plus b. So we can find our y-intercept. So that's 4 plus 2, 4 equals 2, sorry, plus b. So our y-intercept here is 2. So the final equation of our line perpendicular to line L is y equals 1 x plus 2. So that is the end of step 2. Remember, the point in finding an equation perpendicular to L is to get the shortest distance from P to our line. Okay, on to step 3. Step 3, I want to solve the system of equations to get the point of intersection of the two lines. I want this point where they both meet. And you can tell by looking at this that their point of intersection by graphing is negative 2, 0. But now we're just going to solve it using substitution, just in case you don't prefer using graphing. So we have the equation from step 1 was y equals negative x minus 2, and the equation from step 2, which is y equals 1 plus 2, 1x plus 2. So if we solve the system by substitution, I can take this first equation and sub it in for y in the second. So I get negative x minus 2 equals x plus 2. So if I add x to each side, these cancel, and I get negative 2 equals 2x plus 2. And then by subtracting, 2 from each side. These cancel, and I get negative 4 equals 2x. So x equals negative 2. And then to find y, I just take x and plug it back into the original equation. So I get y equals a negative 2 minus 2. So that becomes y equals 2 minus 2, or y equals 0. So my point of intersection will be negative 2, 0. So the very last step is going to be finding the distance from our point of intersection, which is negative 2, 0, and point P, which is 2, 4. So to do that, remember my point of intersection was negative 2, 0. I have to use the distance formula, which is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I can take point P to be my x1, y1, and take my point of intersection to be my x2, y2. So when I plug it into distance formula, I get negative 2 minus 2 squared plus 0 minus 4 squared. So that becomes the square root of negative 4 squared plus negative 4 squared. So remember, anytime you square a negative number, it becomes positive. So this becomes 16 plus 16. And then if we combine 16 and 16, we get 32. You can leave this as a decimal. That decimal is an exact answer, or in a calculator that is approximately 5.7. Okay, so the distance from our point P and our line L is the square root of 32 units, or 5.7 units.